Okay, we're going to call this channel introduction. The whole series is going to be several videos. It's about how we built a poured concrete house, not hollow block, but poured concrete in forms. We reused the forms so far 36 times. We've refaced just about every one of them once and a few of them twice. This series is going to be presented in several different ways. We have a slideshow we can do of construction to got us to the point where we're at now. But I don't know if we're going to do that, at least no time soon. We're going to do videos. I've always liked videos better. Anyway, we have CAD drawings of everything that was done in designing the house, calculating structural loads and rebar, how thick the floors are, how big the columns are, how deep the foundation is and what's down there. The sanitary lines underneath of it with all the fittings drawn in the drawings, everything to scale. So if it's in scale, you draw these things 1 inch equals 1 inch or 1 centimeter equals 1 centimeter. If it fits on paper, it should fit when you put it together. Not saying you can't screw it up, but it's hard. Anyway, we have, this is a CAD drawing that I got up here just so there'd be a picture on the screen and I won't look like the talking head. And the computer's gonna give me problems. Okay. What you're seeing here is a CAD drawing, and this one is of the wall form prints. The walls were done as an 8-foot high wall, and then there's a 2-foot addition on the top, which is a lot wider. That casts the tie beam at the same time as the wall. The concrete's continuous. The rebar in the tie beam is exactly the same as it would be if it was on a hollow block wall. Same number of bars, same placement, same diameter with the beam. It's 24 inches tall, 14 inches wide. The walls are 7 inches thick. Because we weren't going to render this originally, but we'll get into why we had to render it later. But it wasn't from the poured concrete; it was other things. And so we have the CAD drawings. We're going to do your basic walk around tour of the building, showing people working, show rebar being in the hole and tied, and the plastic that goes under the concrete, the chairs we used to raise the rebar up off the bottom so it gets three bar diameters cover of concrete under it, over it, everywhere. But so there'll be walk around videos, and that'll be the most of the presentation. There's going to be, there may be a dozen videos of CAD drawings, but they'll be moving. They won't be sitting stationary. So we have slideshow, CAD drawings, and walk around. Okay, that's pretty much it, I think. And this house has been got up through to the point where we're doing skim coat on a lot of it. But nothing around the house has been done. One of the things we're starting on Monday is finally the septic tank. We have a floor poured 2 years ago when we were pouring concrete for a septic tank, a 37,000 gallon water cistern, and a fish pond. Not really a pond, it's a trial thing to find out if we can keep fish alive in a concrete tank. And if we can, we got in the architectural drawings, there's several of these ponds around this house. The house itself is a decagon shape. I drew a house up, and my software says, that's a castle. I says, that's the number of rooms you asked for. She says it's pretty, but we don't have any kind of decent concrete blocks over there. So we started talking, making blocks, but you have to have a concrete floor to make them against. And if we can't get poured concrete, then we couldn't get ready mix at that time. Now they're everywhere. Because the last 2 years they just proliferated. And concrete pumps. There's 7 of them between here and Manila. 7 places, I don't know how many pumps. There's one of them in town, right where we live. Anyway, I designed it for earthquake resistance out of jack-built blocks, basically, and had a lot of curves and not curves, but buttresses, and it was all right. It had between the joist for the upper floor, it was air circulation for air conditioning and things. The joists were laid out across the walls so that when you cap the bottom off with your ceiling, that you end up with a whole bunch of ducts. And that was designed to distribute air through the house for ventilation and for cooling and things. Anyway, the house was too big. And so she brought me a paper bag with this octagon on it. Draw just lines right across the center, eight triangles, looked like cutting up a block of cheese. And I says, what's that? She says, how could you do a house like that? I says, I can design it to be anything you want it to be. It's your house. Tell me what you want. And she says, I'd like it like this. I says, what are the rooms? Put the names on the rooms. She came back and she says, I got extra names. I says, how many? She says, well, just 2. So I looked at it and I said, well, you're short more than 2. You're short at least 4. So she says, well, add more sides. So we called it a decagon, and we're going to build a 10-sided house. It looks round because the roofs are round and all that, but the building is all straight walls. Everything is straight walls. And the center is a 26-foot diameter atrium. Goes right through the ceiling. There's no ceiling on the first floor. It goes right up to the top of the house above the second level. And it's a whole house fan, 7 meters diameter, sort of like Wilcon Depot has in their stores. Okay. Oh, is there a clock? 7 minutes and 5 seconds. I don't know whether it'll come out when the thing gets uploaded. Oh, while we're on this drawing, you might as well get something out of this rather than just hear me talk. Where's my pointer? Please. Okay, it's on the right-hand half of the drawing. These things around the outside are all the parts of a form. There's a piece of plywood here, and it's got screw holes marked. It's got the bolts drawn in. It will go to another panel. It's got access holes over here. There's six. The access holes are only on the back side, not the front. That's so you can get in and put a wrench on these bolts that ties forms to forms. Like this, where it says top, if it was right side up, I've turned it over somehow. This would be on the outside, these holes here. And the next form would bolt going up this way. There's nothing on the top of the form. That's just trowel, absolutely slick with a trowel. We're going to make a bearing out of it, so it's really troweled really smooth. The bottom, this bolts onto the top of another form. And I was trying to work the thing with looking at the camera screen. Okay. This is a 4x8 sheet. It's got a solid sheet on the side that faces the concrete. And the back side, as is the 2-foot tall one we just looked at, same thing. You got a piece here that goes from here to the edge. That's 16 inches wide, because you get 3 pieces out of a 4-foot sheet of phenolic board. So this is airspace right here. This makes it into an I-beam. It's got flanges, and the flanges are right where it all bolts together. Same deal with an access hole to get to the bolts, but you can reach through here. We made these holes 3-inch, and that was too small. Made them with a hole saw, and we used them about 4 or 5 pours. And what we were using was 6 and 12-inch half-inch drive socket extensions and a ratchet handle out here. We had an electric wrench, but there was a lot of resistance to using it, putting things together. But taking it apart, they loved the electric wrench. And after they used it a while, they wouldn't want to start until they had all the tools out there. Then they'd go get it. Okay, these little dots all around, see, they're really at a 45-degree angle. They're not just right across from each other. There's I don't know if you can tell. Anyway, these marks the screw holes. So we printed on my large format printer back in the States. I got a machine shop back there. We printed a full-size pattern of this. So my wife Aurora, she's made curved forms and stuff on the bandsaw, and rather than lay things out, we would print something, and she uses wallpaper paste to stick the drawing onto the wood. Then she saws it out, and in this case we stuck it on with wallpaper paste, and we drilled all these holes for bolts, for the screws that holds it all together, and then this top one we wrote pattern on with a art line paint marker, not a glassboard marker because that rubs off. You have to use a paint marker, and that let us stack these sheets up 3 sheets high. You know, 3/4 inch finality boards, one on top of each other. Drill through the open hole that we just drilled and into the next 2 sheets. You only have to go through the first sheet and part way through the second sheet, because when you unstack it, you can finish the holes. And we have 5 pairs of these, so there's 10 total sheets of plywood on that, and a half a sheet for making the back. So that's 15 sheets of plywood in our forms, plus the little 2-foot high one up here, which is significantly less plywood because you get 4 of them out of a sheet. The wood around the outside is 2 by 3. It turns out that where we bought it, they sold us Nara, which is completely rot resistant as far as we can tell. There's furniture made with it that we have in the house here that's 30 years old, looks like new. I would not have cut up a rare species and made concrete forms. I just wouldn't have done it. But now we got it done. These things have lasted a couple years, and the wood is in fine shape. When we get done with forms, we're going to strip the Nara out, and we're going to plane it, because it's not all the same size. You have to buy a bunch of it and then stack it on edge and pull one over and find a pair to it, match them up until you can get something you can put together that's flat. So the difference in the thickness of these forms varies like probably 5/8 of an inch from one form to the other. And we measure, all the measurements are measured off the front face that meets the concrete. So when you bolt it together, the bolts go through and the sheets are flush with each other, but the back side just wherever it happens to be. We have patterns made up, but these were laid out with a framing square right on the wood. We made one, and then we made the duplicates. So 10, 20. We made 40 pieces of this, and the same with the tops and bottoms. We're using 1/2 inch bolts in 5/8 holes. It's really not too sloppy. Sometimes you have to use a wrench to spin them out. They don't even want to come out. Let's see, what else is going on here? I think this is, this drawing over here. This is so that we could have the horizontal rebars, the red ones, the vertical rebars, which are blue ones, and we had to put holes through these sheets to bolt a spacer between the 2 panels. So we had our sheet over here that was our sample or our pattern. It was the full-size sheet. We put these lines across it because we have dimensions. You see a few of them hiding here. 10 inches on center, going up and down. And I think it's either 9.5 or 10 going the other way. It works out to where a bar ends up on the seam, and that way there can't be any bolts going through the bar. That's a freebie. Anyway, we have 4 pipes, put 3/4 inch orange PVC, 7 inches long. It goes through the first whole form over here. Then you hang the orange PVC pipes on it. Then you tilt up the form for the opposite side and shove the bolts on through and put a washer and nut on them. You don't want to tighten those things. You just want to run them down more than your fingers, because you can distort the form, and you can crush the. I think the term is swage, the plastic pipe where they won't slide back out, and then they become permanent in the wall. Or at least they're the devil of a thing to get out. And we use schedule. I think it was schedule 20 3/4 inch pipes. You can get those at your hardware store. I don't think I'd want them in my house, but because you can get schedule 600 at the same place. Schedule 1000 is really too heavy for electrical work because it closes down the hole inside. Anyway, we screwed these things together with the first things we built. We used Phillips head screws with a 268 DeWalt screw guns for metal buildings. Got a clutch on it. You can set the torque so you don't just break the screws right in too. We found them hard to get back out. They slip on the bits once in a while and round out the screw, or they ruin the bit. So when we came back the second year, we brought Torx head screws, the same lengths. It was 2 inch for the any place we did phenolic board, and it was 3 inch for the longer screws. So it was a T20 for the 2 inch long and a T25 for the other ones. And if we used 3.5s, we had I don't know, maybe 80 pounds of 3.5s also, and those are also T25. Besides the 268 DeWalt screw gun, you can get a 272, which is for putting up gypsum board. Same torque, as best I can tell. It will take a screw and either run it right through that Nara, or it will ring it in two. So when we were working with Nara, we pre-drilled the holes. When we're just putting it into cocoa lumber, we just put the screw up there and hit it with the screw gun, and it never broke. Well, we might have broke a dozen, but we've used those screws probably 25 times. We save them, every one of them, and throw them in a Coke Zero bottle about 2 inches old in the bottom and shake them up. And they're hard to get out, but the screws don't go bad. And you take them out, even if they've been on the concrete face, like when you're changing these phenolic boards, put a 2.5 millimeter cobalt drill, like a 6% cobalt. You just put it in the hole for the Torx and rattle it around. When you take your drill back out, turn the air flow out of the drill in it, and it'll blow the dust away. And that completely clears the hole out. You put your Torx bit in, and away it goes. So Torx bits, doesn't hurt to have a pattern sheet of your screws. See, if we take these, if we take these sheets off, and we want to use the back side of the sheet, which has never had concrete against it, if we flip it over, this screw, which is closer to that end, on the other end, the screw that came out will be down, and that screw will be up. You get a fresh hole. No, there's never been anything in that piece of wood at that point. You've got 3/4 inch of good wood all the way around your screw. So you can flip the piece. You can't turn them in for end because these pieces in here are get closer together to the bottom because there's more pressure on the concrete, more hydrostatic head. So they're not evenly spaced. There's an inch or two bigger spacings up here and here, and they get tighter as you go down. Oh, let's see, I can move this. Okay, this down the bottom would be floor level, and of course these vertical bars sit right on the floor. First red bar, it's 5. Looks like it's 3 inches off the floor, and then it's 5 inches to the next one, and then from there to the first one that starts to 10 inches, it's another 5. So it's 5, 5, and 3.219. And we don't go to 4 decimal places, but the drawing saves it to that. Anyway, this shows you where the bars are closer together near the tension side of the concrete. We really have no tension side to the concrete. the floor was poured over the entire house, one end to the other, in one shot. Except it's poured by rooms over top of the tie beams. The center of the tie beam is the joints. And that lets the floor be foundation. You have to push that whole floor into the dirt for this floor can go down, or the wall can go down. So there's really no tension side. But if we were pouring this right on the tie beams, then this would be a good move, you know, to get more strength down there where you could run a crack from. What's the time? Oh, the time was plenty. Okay, channel introduction. I'm going to call it, we call it Chapter 1 or Episode 1, I think Chapter 1. And, oh, the next few intended things will be building permits. You have to have if you're an expat, only if you're an expat, you have to have a building permit. Even if you've got a Filipino wife or a Filipino husband, you have to have a building permit if you're one of you from out of the country. And you're going to have to be a little patient with them because they don't do too many building permits. There's probably 10 or 15 issued for our area in a year, but there's 100 houses built. We haven't displayed ours because it took us almost 10 weeks to get it, and we didn't want it to get wet or damaged. Because if you lose a piece of paper here, you start from scratch. You get a business license, you have to redo it. In 51 weeks is when you can start. But you do every piece of paperwork like it's the first time. You can't just get an extension or whatever. Electric utilities, you want to get them to put a temporary pole in before you even clear the grass and weeds off your property. It'll be good for 3 months and sometimes 6 months, but maybe it's 3 months the first time and you can renew it 6 at a time. That's money well spent. We have not got electricity yet. The house is nearly wired now. We still haven't qualified for electricity because the only thing we can get now is permanent installation, and they won't do it this far along, and they wouldn't give us the other pole because we're expats. We had to have the provincial engineer, electrical engineer, and a licensed electrician and 2 electricians helpers on site during the entire installation of our temporary two wires to the pole. Getting all those people to the site on one day, and then they think you're crazy when you ask them to do that, you know? But that's what the paperwork from Moralco said we had to have. There's lines and names and license numbers, places and dates, and there's a couple, two or three sheets of paper. But we just, we got caught between having broke ground because we had a building permit and being finished wired. We're in that gray area, so we never got electricity. The water's not as much problem because it comes from an individual. The government does not supply the water in our town. It's a private concern. And they don't seem to be too hard to deal with. I just had so much struggling with electric, I didn't want any more headaches, so I just didn't do it. We have a hand pump well on the property, and there has been a lot of water pumped. Anyway, so the next intended video is going to be the first of the sheets for the building permit. I think there's 7 sheets altogether. We had 8, but I'm not sure what that other one is. I don't think it's part of the building permit. It may be, but we have 7 here, and you have to have 8 copies of each one because all the 6, I think there's 6 places you have to drop them off. You hand carry them there. Then you come back in a week and a half and see if they've 1 read them and 2 signed them. If they sign it, then they'll sign your master copy, which you're going to turn into the mayor. He's the last stop before you get a building permit. And then 1 set is for you, and that'll be signed. So when you go to pick them up, you carry the one for the mayor, and you carry yours. And 1 sheet has got a place for like 8 signatures down the right-hand side, and the rest of them just have like 1. If it's the sanitary, only 1 guy signs off on that. And the one for the fire department, only 1 guy signs off on that. So you don't have to have all the little blocks down the side of the paper. It just makes it look like there's something missing. Okay. I have done some some videos along the way, but I have not got anything uploaded at this point. I ruined this introductory thing once, and the first building permit one, I screwed that one up too. And then a couple of random ones download or uploaded to YouTube. I don't know if anybody could see them yet. They're marked public, but I don't know if they're really out there yet. But I'm going to check back if I ever get an introduction and at least 2 or 3 videos actually that will play. Then I'm going to make sure that that part's working. But that's up to them. I don't know who to call or what you talk to. Anyway, bye. Bye. Oh, wait a minute, one thing. They always say if you like it or you gain anything from it, thumbs up is not necessary but appreciated. And it would be. There's also a thumbs down. If this video and the whole concept is totally crap, if you can go thumbs down. There's no problem with that. But I'd like a comment knowing why it's such crap. I might could improve it for you or anybody else. So if you're gonna do thumbs down, I'd kind of like you to tell me why it's so awful. But now I'm gonna see if I can turn this camera off.